Hello everyone, today is day 73 of solving a LeetCode problem every day, and today I'm going to solve k closest points to origin. So given an array of points where points I is equal to xi, yi, so these just represents points on the xy plane and an integer k, return the k closest points to the origin, which is just 0, 0. The distance between 2 points on the xy plane is I don't know how to say that, but you can get it using this formula, and all this formula is just pretty much the Pythagorean theorem. So like we have a squared plus b squared is equal to c squared, and then like since we're finding the distance between like 2 points, we have just like x1 minus x2 squared. And the reason why this whole thing is squared is because if you just want to find c, the distance, you would have to square root this side and this side, which is why it's the square root. So you may return the answer in any order. The answer is guaranteed to be unique except for the order that it is in. So it's just saying that all distances are going to be unique from each other. We're not going to really have duplicates, and we can return the answer in any order, so it doesn't really matter what order the answer is in. We just need the k closest points to the origin. So like an approach you might take is like in an array, maybe calculate all the distances, and then once you calculate all the distances, you can sort it and then get the closest points. But there's probably a more efficient way to do this, and we're going to do it using a min heap. So the general idea is we can store all these distances in a min heap, and then we just pop the k closest elements. It's that simple. So first of all, we're going to start out by initializing our min heap, and then we're going to say for x and y endpoints. So what we're doing now is to this min heap, we want to calculate all the distances. So once we heapify the heap, it will be in order. So we're going to say distance is equal to, so another thing I want to mention is here we have x1 minus x2, y1 minus y2, but we're trying to compare it with the point with the origin 0, 0. So x2 and y2 don't really matter because they're just 0. So any number minus 0 is just the number itself. So we can ignore that, and we can also just ignore the square root. We could do the square root if we wanted to, but it doesn't really matter in this case because, for example, we had like 5 plus 5, and we square root that. We know that's always going to be bigger than, for example, 2 plus 2, and we square root that. So whether or not we square root the equation, we're still going to have the same ordering of things. So what we're going to do is we're just going to say x to the power 2 plus y to the power 2. And that's going to give us the distance. Not the distance exactly, but just some type of representation of the distance. And then we're just going to append to the min heap. So in our output, it says, we can look at it over here, for example. We have k equals 1, and it wants us to output the xy coordinates. So we also got to keep track of what we got to, like, alongside the distance, we also have to keep track of what the xy coordinates are that correspond to that distance. So what we're going to do is to the min heap, we're going to append a list, and this list is going to consist of the distance alongside the xy coordinates. Cool. So we got the array built out, but now we need to actually heapify the heaps. We're going to use the heap queue class, the heapify method, and we're going to pass in the min heap. So now this gives us our heap now. So now we also want to initialize our response, so our output, and now we want to output the k closest elements. So what we can just do is we know that since this is a min heap, the root is always going to be the minimum distance. So all we need to do is just pop k elements out of the heap. So what we can do is say while k is greater than 0, what we're going to do is we're going to deconstruct what we're about to pop. So we're gonna say distance x and y is equal to heap q dot heap pop, and we're just gonna pop from the min heap. And then we're gonna say response dot append xy and k minus equal 1. So right here, we're just going to pop k elements, so the k closest elements. And finally, we can just return the response. So if I run this, submit it, accepted. Okay, so now let's go over time and space complexity. So let's just kind of go over everything. So this right here is going to be an O of n operation where n is equal to size of points. And the reason why is because we are just processing each element in points. These two are constant time operations, and we're doing so we're doing it n times, which is why it's O of n. Now for heapify over here, this is another O of n operation. And then here, well, first of all, we know we're going to do k things. So it's going to have to be O of k to start out because we're doing something k times. Well, I'm not going to type it out where k is just equal to k. So the number of closest elements that we're looking for. And then each heap pop operation is a log n operation. So this is going to be k times log n because we're going to perform a log n operation k times. So basically in total, the time complexity is going to be O of n plus k log n. So really it's just like n plus k log n. And I mean, if you really want to get specific, I mean, I would just leave it like this just because we know that k can be at most of length n. Yeah, so I mean, this is really just going to be a n log n time complexity for the worst case, just because, you know, the worst case scenario is k is equal to the size of points. It wants all the elements from points, which is why we're going to say the time complexity is n log n. Now, as for space complexity, let's see. So the actual min heap itself, we're going to store points, and that's going to be of size n. So the space complexity is going to be O of n because, you know, response is going to be of size k, but worst case scenario, it's going to be of size n. And so we're going to have like n plus n, which just simplifies to O of n. And yeah, that's my solution for the day.